record this. Now, we had been doing this, which we were talking about buffer solutions, right? What was a buffer solution? I told you, okay, it's a solution that's made up of a weak acid and its conjugate base, which in this case would be like if there is NH4 plus 1 and there is NH3, the conjugate base, both of these are present, right? So that would form a buffer solution. What it would do is that if you start adding H plus 1 ions into the mixture, then the concentration of these H plus 1 ions will not increase. Why? Because the NH3 would start gaining those H plus 1 ions to form NH4 plus 1. So it's going to gain H plus 1 ions to form NH4 plus 1. Just let me just... So here, I just switched the internet connection. So I said that if you try to increase H plus 1 ions, the NH3 would gain those H plus 1 ions, and it would form NH4 plus 1. So all the H plus ions are going to get used up. Similarly, if you start adding OH ions into the mixture, what's going to happen is that the NH4 plus 1 would now start releasing or would start reacting with the OH ions. The NH4 plus 1 would give away its H plus 1 to neutralize the OH ions, and the OH ions would turn into water. So all the OH ions are going to get neutralized as well. Okay, Lubena, is this clear?
Yes.
Achha, so we were dealing with this question which we had, we said that there was NH3 and HCl being mixed. So what happened was, did you send me the answer to this?
No.
Achha, so I
can send it right now.
Achha, just let me quickly tell me how many moles of NH3 are you adding? What's 500 into?
5 multiplied by 10 is -3.
Negative 3?
Yes.
Or negative 2? It's 0.1 into 0.5, right? So are you sure it's 10 by negative 3? So let's go with that. Are you sure?
Sir, I made a mistake. It was 0.05.
Okay, so this was 0.05, right? So you had 0.05 moles, right?
Yes,
and how many moles of HCl are we adding?
0.03.
So we're adding 0.03 moles of HCl. So HCl is added. Now NH3 is in excess. So 0.03 would get it's going to completely react. All the HCl would be gone. It's going to react with 0.03. So there would be 0.02 moles of NH3 that would still be left at the end of the reaction. Is this clear?
Yes, sir.
Okay, so 0.03 react and 0.03 of this also react. And on the other side, you're going to get 0.03 moles of NH4 plus 1 or NH4 plus 1 Cl minus 1. They're the ones that are going to get produced. So your mixture at the end, it's going to be a buffer solution. It's going to have NH3, and the moles of NH3 are going to be 0.02 moles, and it will have NH4 plus 1. and the moles of NH4 plus 1 are going to be 0.03 moles. So your solution is going to have this. The next thing you're going to do is you're going to use the dissociation constant K, which is the conjugate base concentration. I mean, it's basically this equilibrium that is set up between NH4 plus 1 and NH3. You have a dissociation constant for this. It's going to be NH3 concentration, which is 0.02, into H plus 1 concentration, which I don't think we know that, and divide by the concentration of NH4 plus 1, which is 0.03, and the K value is given as 5 times 10 power minus 7. What is the answer that we got for this?
3.3 multiplied by 10 to the power of -7.
So 3.3 multiplied, I mean, that's H plus 1. You're getting H plus 1. And what's the pH then?
6.47.
So we're getting a pH of 6.47 when we solve this. So that's one type of question we're going to get. And we did another, we did some questions. Yes, we were doing, we did the simple questions first, and so we did the equal concentration question as well. So we're going to do another slightly more difficult question. Now, this question is about creating a buffer. What the question states is, I mean, this is a difficult one. Most people were not able to do this question. It's a buffer solution question. It's the same one. The container has two things. It's got a weak acid. It's got a conjugate base. Both things are present in the container. So there is ethanoic acid plus there is ethanoate ions. Both things are present. What he's asking for is, you're supposed to create a buffer which has a pH of 4.8 and it should have a volume of 100 cm cube. And you're given two things. And those two things are ethanoic acid and sodium ethanoate. So you're going to add sodium ethanoate to it, which is CH3COO -1 and Na +1. So you're going to add that, and at the same time you're going to mix ethanoic acid into the mixture, right? So weak acid plus its conjugate base, they're going to form a buffer. Now the thing is, when you mix them up, this is 0.1 mole per dm cube. I mean, you know the concentration, and this is, let's say, 0.25 mole per decimeter cube. So you know the concentration of both things. What you don't know is what volume are you going to mix. What volume of ethanoic acid and what volume of sodium ethanoate is going to be added to the container to make up a solution that is 100 cm cube. Is this point clear?
Yes, sir.
So you have to make up a solution that's 100 centimeter cube. The only confusion is what volume. Now remember, this is the starting concentration. This doesn't mean when you mix two solutions, what happens? Do you know what happens to their concentration if you mix two solutions? Does their concentration remain the same or does it change? Like if I'm going to mix 0.1 mole per dm cube of this thing with some volume of 0.25 mole per dm cube of this thing, what would happen to the concentrations? What would happen to the concentration of this thing? Would it change or would it not change?
It wouldn't change.
So I'm going to show you an example. Let's say I have a container and I added some solution into it, right? It has a particular concentration. So I've I've added that solution already. So the concentration stays the same, nothing happens. Then I add another solution. Let's say you've got, then I add another solution, right? This is solution X. Then I start pouring another solution, and that one is solution Y. When I mix two solutions up, the first thing that happens is that, the first thing that happens is that the volume starts to increase, right? When is this clear? That the volume has started to increase.
Yes, sir.
I say, so whenever you mix two solutions, but the moles of X are the same. I mean, they haven't changed. You added this much, they're going to remain the same. You're adding another solution to it, so the volume has started changing because of adding this other solution. So the number of particles, they kind of remain the same, right? And all these particles would be, they're going to be all over the place. So what do you think is happening to the particles of X? They're going to become more dilute. Is this idea clear?
Yes.
And why do they become more dilute? Because you have the same moles of particles. Moles, concentration is moles per unit volume, right? So that's still constant because you didn't add more of X, it's the same X. You added another solution into it, so the volume has changed. So the volume increases. And when the volume increases, that's why concentration decreases. It becomes more dilute. I mean, there are obviously going to be particles of the other substance which you are adding. I mean, there might be, particles of Y in the solution. But if you just look at the number of moles of X, they're the same, but they occupy a much larger volume. So they're going to be more dilute. Right? Is this clear?
Yes, sir.
So remember this point that solutions, mixing of solutions ends up diluting both solutions. As our volume increases. So it ends up diluting both solutions. So the same applies over here. Like if you take ethanoic acid and you take sodium ethanoate, you mix both of them up, both of the concentrations are going to change. So the point is, how do you solve this question? Because they're asking for the volume. How much volume of this would be added? And they've given us the Ka value of ethanoic acid. The Ka value is given as 1.8 times 10 to the power minus 5. That's already provided. So they've given us that. So they've given the K value, and you just have to find the volume of each thing. Now, how would you solve this? The total volume is 100 cm cube. So that means you might add 80 cm cube of this, and you might add 20 cm cube of this, or you might add 50 cm cube of this, or you might add 40 of this and 60 of this. So the total volume must add up to be equal to 100 cm cube. Is that clear?
Yes, sir.
So I'm going to assume the volume that, let's assume that the volume that I'm taking for ethanoic acid is X cm cube. So what would be the volume in terms of X of sodium ethanoate?
100 minus I.
Okay, so that's 100 minus X in centimeter cube. So now I have the volume and I also have the concentration. Both things are given, so I can find the moles. Moles would be concentration times volume, so it's going to be 0.25 times X, and the whole thing gets divided by 1000. Over here, your moles would be concentration times volume, which is 100 minus x. And I'm going to divide that, the whole thing, by 1000. Okay, is this clear?
Yes, sir.
So I found the moles, like how many moles I'm adding in terms of x, how many moles of this I'm adding in terms of x. Now I have to find the new concentration. Now these moles that I've added, the concentration of sodium ethanoate would be moles divided by volume, right? So it's going to be moles divided by volume. Now these moles are now present in this new volume. The new volume is like now I'm trying to find the concentrations after they've mixed up. So the new volume is now 100 cm cube. So I'm going to divide it by 100 divided by 1000 in terms of dm cube. Is this clear?
Yes.
Okay, concentration is moles per unit volume. So these moles are now present in this entire volume, which is 100 cm cube. Same goes over here. I'm going to try and find concentration. Concentration would be, it's going to be moles divided by volume. It's going to be 100 divided by 1000, right? So I found the concentration of ethanoic acid. I've found the concentration of sodium ethanoate. Both are found. And I have the pH, and I also have the K value, which is given as 1.8 times 10 power minus 5. So what is K? K is, so what is K? K is 1.8 times 10 power minus 5. And it's the conjugate base concentration, which is this one, divided by the acid concentration, right? Is that clear, Lubena?
Yes, sir.
I said, now since both things are going to get divided, so a lot of things would automatically get cancelled out. Like the bottom denominator would get cancelled out, right? This 1000 would also get cancelled out when you're dividing it. So it's just going to be 0.1 into 100 minus x. And that would be divided by 0.25 times x into the concentration of H plus 1. We have the pH, so H plus 1 would be 10 to the power minus 4.8. So we have that value as well. It's going to be 10 to the power minus 4. Okay, is this clear?
Yes, sir.
So we've gotten this far, and what we just need to do now is we just need to solve for x. That's it. So I'm going to try and solve for x. It's going to be 1.8 times. I'm just going to use k and rearrange the whole expression in terms of k. Then I'm going to substitute the value of k. So it's going to be k into 0.25x is equal to, and I'm just going to call that H plus 1 concentration. So it's going to be 0.1 times 100. Okay, let's keep it as 10 power minus 4.8, and minus 0.1 times 10 to the power minus 4.8 times x. And we solve for x. If I take x as common, it's going to be 0.25x, 0.25k plus 0.1 into 10 raised to the power minus 4.8 is equal to 0.1 into 100 into 10 raised to the power minus 4.8. I mean, I took this on the other side, and this entire thing has to be moved into the this entire thing has to be, so this is your expression now. So just try and solve what you get for x.
6.39 multiplied by 10 to the power of negative 4.
You shouldn't be getting that. It's did we make any mistakes? Just a second. I mean, this is just carefully going over this. This is 0.1 times 100 minus x. That's the volume, right? No issues there. This is 0.25 times x. So that's your moles. The other things would get cancelled out eventually. Conjugate base divided by so it's going to be Ka divided by the conjugate base concentration 0.1 times 100 minus x divided by 0.25x into 10 to the power minus 4.8. And we took this to this side. Let's try and solve this stepwise. Can you take us step by step? I mean, I tried to do this all in one go. So let's ignore this. Let's be careful when trying to solve this. So just pH is 10 to the power minus 4.8. That's fine. That's h plus 1. 100 minus x into what is point? So that's 0.1. So everything looks good. Sorry. Hello, can you hear me?
Yes.
So can you tell me what's 1.8 times 10 to the power minus 5 into 0.25? What value do you get?
Sir, do I have to calculate 1.8 multiplied by 10 to the power of negative 5?
Into 0.25. I mean, K was a constant.
4.5 multiplied by 10 to the power of negative 6.
So it's 4.5 times 10 to the power negative 6, right?
Yes, sir.
Acha, what about this thing? What do you get for this? 0.1 into 100 into 10 to the power minus 4.8.
Uh, 1.58 multiplied by 10 to the power of negative 4.
And what is this?
1.58 multiplied by 10 to the power of negative 6.
And that's x, right? And bring this to the other side so the x would get added up. Add this with this.
Uh, 6.08 multiplied by 10 to the power of negative 6.
Negative 4. And try and solve for x now. So I think your answer was all right. What's the answer now?
25.9.
Kitna? See, now it's 25.9.
Yes, sir.
See, that makes sense. So I think this is the correct answer. That X comes out to be 25.9 because the total volume is 100 cm cube. So X is 25, like there's 25.9 cm cube of this, and the rest is whatever 75 or 74.1 cm cube of this. Is this clear?
Sir, could you scroll down just a bit? Sir, where did the 10 multiplied by negative 4.8 come from?
The pH was given that the buffer solution should have a pH.
Okay.
So it's a conjugate base concentration divided by acid concentration into H plus 1. That's Ka. TK, is this question clear?
Yes, sir.
So this was a tricky question. I mean, when this came, no one was able to actually solve this because they were looking for the volume. They were kind of looking for the volume of your. So one other way that I suspect that this question could be answered is, and that is, that would still require a lot of calculations. It's going to be the. No, I mean this is probably the most convenient way of solving this question. Now, so you get questions. This is one of the hardest questions. So you're going to get different types of questions. You might get questions linked with moles where the end result is that you form a buffer, right? Or you might get a very straightforward question like we were doing earlier. If you have a very straightforward question, they'll just simply give you the concentrations. They'll give you the K value. You just have to find pH. So you might get questions which are very straightforward. You might get questions which are linked with moles, and you have to figure out what's the situation at the end of the whole reaction. Or you might get some tricky question like this. So now, moving on, we're going to do more when we do past paper practice. So moving on, the next thing that we're going to try and do is, let me just. So the next thing we're going to try and do is, that is pH curves. So pH curves it's linked with titration. And when you're titrating something, what happens is that so when you're titrating something, what happens is you have a burette. The burette might have a base, so maybe there's NaOH present in the burette, and at the bottom there is probably a conical flask, and in that conical flask you'll have some acid, let's say ethanoic acid. So in that conical flask, you're going to have some ethanoic acid, and what would be the pH? What would be the initial pH? I mean, this is the graph that they'll be looking for. So there are going to be two axes. One axis would be, you'll be sketching the pH. On the other side, there's the volume of NaOH that's being added. So you'll have 3 points. I mean, at the start, what's the pH? It's going to be acidic, right? Because you have an acid in it. So when no NaOH was added, like there was absolutely no NaOH, the solution was acidic. Maybe it's a weak acid, let's call it 4.1. So I'm just using made up values. And then there's going to come a point when you start adding NaOH, the ethanoic acid would start to react with NaOH. And it would start turning into a salt, and would also at the same time form water molecules as well. So there would come a point when all the ethanoic acid reacts. So that is when the pH would be neutral. That's known as the equivalence point. I mean, this is the point when you do titration. Whenever you do titration, this is the point where the indicator should change color, because this indicates that all the ethanoic acid has reacted. Is this clear?
Yes, sir.
And then even if you start, if you don't stop the NaOH, then there's going to be excess of NaOH. Now there is no ethanoic acid to react with. So you keep adding this NaOH, the NaOH goes into excess, and the solution would become alkaline. So at the end, like if you don't stop, the solution is going to turn alkaline. So there are going to be 3 points that you're going to plot. And most of the time, the curve, when you sketch the curve, it kind of looks something like this. It's an S. So it's an S-shaped curve. And in the next class, I'm going to explain why it's an S-shaped curve. But forget the shape of the curve at the moment, but just remember there would be 3 points that you'd be trying to find out if you want to sketch a curve. You'll try and find what's the starting pH. Where do you start the curve? Then you'll also try and find at what point, at what volume of NaOH has all the ethanoic acid reacted. That would indicate that equivalence has reached. The pH should be 7 at that point. So you're going to try and find this point, that at what volume of NaOH has all the ethanoic acid reacted. And then you're going to try and figure out what's left at the end of the reaction. Like once you've added all the NaOH, what is present right at the end of the reaction. ठीक है? So ये सारा हम discuss करेंगे कल, ठीक है? Lubena, any questions about what? I mean, that question is clear, right? The previous one.
Yes, sir.
So ठीक है. Let's continue tomorrow.
Allah Hafiz.
Okay, Allah Hafiz.